Hello, my name is Chris Scarlett. I'm an educator, designer, and budding product developer. In this course, I'm going to demonstrate a method in how we can use simple SOLIDWORKS weldments to build a complex structure. We will be constructing a powerline tower leg structure in order to demonstrate this method. What makes a structure complex? Perhaps structures without angles, not at right angles, non-axially symmetric structural members with L-angle or rectangular profiles, and because of the previous, this provides a structure that's difficult to measure. Lots of parts? Not always. You can have a complex structure with few parts, as in our tower leg structure example that I will be demonstrating as part of this course. So, why weldments? Well, using a typical weldment reference geometry of a 3D sketch, these sketches are easy to visualize and measure between lines and line endpoints. We're also going to use it for control. Also, weldment structural members are well automated into compact features. They're essentially automated sweep features, and we're going to take advantage of these benefits. So applications that you can apply this method to may include anything involving connected structural members. In our example, the intent is to bolt them together. In spite of the name, we're going to be using weldments, but we're not going to weld a thing. So let's take a look at a powerline tower leg structure that we will be modeling as part of this course. So how do you get all these structural members and connection plates aligned with each other along with their hole placements? The solution is the creation of a multi-body part using reference line sketch blocks and SOLIDWORKS weldments. So let's take a brief tour of our model and take a quick look at our methods. From our assembly, you can see the complexity of some of the connection plates and structural members and how they come together accurately aligned, including coordinated hole locations. Opening up one of our tower leg structures, you can see the cat and hat colored reference line sketch blocks that we're using for our weldment path segments. As we move in closer, we can select one of these sketches, modify a dimension, rebuild our model, and the structural member updates, as well as the related structural members it's associated with. A benefit of employing this method of reference line sketch blocks and SOLIDWORKS weldments is that these modifications can easily be made in the modeling area with very visible and selectable sketch geometry. Once made, all the related structural members and their coordinated alignment points and hole locations update too, accurately and without error. As we move up our model, all the related structural members associated with this recent modification update too, quick and easy. Now, not only can changes be made to small groups of structural members, but large changes can be made to the generalized size and shape of the model by modifying just a few elements in a couple of design sketches at the top of our feature manager. In the remainder of this module, we start with the basics of creating our design sketches needed to control a large model like this. Then we introduce you to the basic application of weldments. In Module 2, we introduce you to the reference line sketch block method for creating our reference geometry for a support leg. So in less than an hour, you will have the basics needed to start your own project. But if you need more, in Module 3, we demonstrate the introduction of more structural members along with coordinating the alignment and hole locations between them. In Module 4, we add even more complex structural members, including some non-weldment angle connection plates, and then prepare our model to mirror from the front side to create the left side of our model. Module 5, we create 4 simple configurations by leg height. We create a powerline tower assembly, and then take a tour of our powerline leg structure, including structural members on the back of our structure. Now we'll look at some more complicated sketch and model geometry to complete our design. This is an important course in learning how to apply a method for designing and controlling a complex structure. It will be designed quickly and correctly, where structural members, connection plates, and holes are all aligned, while also ensuring that the model is easy to modify and without errors. Whether you watch an hour or the whole course, you will learn how to apply SOLIDWORKS weldments and the reference line sketch block method in the design of a complex structure. Okay, so let's get started. What we want to do is we want to create a whole new part. We're going to start right there. We're going to go up to File. We're going to go to New, or we can go up to the New button up here as an alternative. But go to your template folder. What you want to do is you want to choose your inch/pound/second part file. And typically what we're going to be doing here is we're going to be designing this in English units, and we're going to be using architectural units here too. So we're not going to be concentrating on inches necessarily as much as we are going to be in feet. So we're going to be kind of adopting the architectural standard for putting this tower together. So if you think about it, a foot is about roughly, it's a third of a yard, and a yard is roughly equivalent to a meter. So if you want to do this in meters too, you're welcome to do that. But I'm going to, from this point on, we're going to be using English units using the architectural standard. So we're going to start with the inch, pound, second part. We're going to go to OK. And with that previous thing said, we're going to go up here to our units, to our options. We're going to go to our document properties. We're going to go to units. And we're going to go ahead and adopt a custom, or click on the custom radio button up here. What we want to do is we want to adjust the length instead of inches. We want to go ahead and scroll down a little bit and go to feet and inches. I think all the other settings that we have in here are probably okay. We're going to go ahead and keep that. We're not going to concentrate on that very much within this course. So with that said, everything else is going to stay the same. We're going to go to OK, and now we're ready to get started. So we're going to start with the top plane. If we click on the top plane over here in our Feature Manager tree, go to the Sketch tab on Command Manager. We're going to go to a center rectangle, and we're just going to sketch this out roughly a square. And while we have this all highlighted, what we can do is go down here for construction. We're going to make that, we're going to make everything here for construction geometry. And we're going to go to a smart dimension. We're just going to dimension one side. We're going to make that 12 feet. So one way to enter that is just kind of a shortcut that SOLIDWORKS adopts, and AutoCAD and Revit Architecture does that too. If you type in 12 and then a single quote on your keyboard, that's the shortcut key for feet. And then go to the green check mark. Now we have that in place. We want to make sure that all of our sketches are going to be fully defined. So let's go ahead and select on two sides over here, and we're going to make those equal. By doing that, now we have a square. We have our reference geometry in the background, and we're about ready to go. So let's go ahead and rebuild this. You'll notice it does say a negative sign over here. It shows a negative sign in our Feature Manager tree. But I think if we rebuild this, we should be in pretty good shape. It should get itself fully defined. With that sketch one, let's go ahead and rename that. I like kind of doing this, especially in a model that I know that other people might be following behind me, and they could probably need some sort of guidance or roadmap as to what each one of these features, and maybe the sketches of these features actually represent. So what I like to do is label these things. It doesn't take a whole lot of time, but it does make it very descriptive when other people are trying to, work on your projects. So we're going to call this one our top sketch. So our top sketch is on the top plane. We're going to create another plane here in just a few minutes. That's going to be top plane -1. And we're going to have a top sketch -1 here too to correspond with that plane. So our next step is going to be creating a new plane, a new top plane. So we're going to go over here to our Feature Manager tree. We're going to select the top plane over here. And kind of a shortcut here, as opposed to going up to Features and going to, reference geometry up here and choosing plane, we could actually choose a plane over here with the Control key depressed and drag that plane down here. You want to drag it down about 7.5 feet, 7 feet 6 inches. So kind of close. It says 8 feet over here, but let's go over here to the distance dialog over here in our Properties Manager. We're going to type in 7 feet, single quote, and then 6, double quote, and that'll put that in there. Or as an alternative, you can type in 7.5 single quote. Now put us 7 feet 6 inches. Green check mark. Let's go ahead and label this. Again, just like I said before, we want to make sure that we label these things so we can find our way around. If other people are working our work, they can find their way around too. And we're going to call that top plane -1. Now, the reason I'm calling it -1 or -1 is if you think about the orientation of our tower, that we're going to have the upper part of the tower up here, which is going to have the bridge up top, which is going to have the structure up top, which is going to have the wires that are going to be suspended from it. And then the bottom part of the tower is going to be a little bit variable. The top part of the tower is going to be fairly static. It's going to be pretty much the same from tower to tower. But what's going to differ in these towers as you go up over hills and into valleys as the towers are going from their origination to their destination is that the legs are going to vary in height. So we're going to have 4 different legs, one leg part with 4 different configurations, which are going to be based on the different leg heights that we need. And we want to conceive this as, having the planes on the bottom part of the tower as being in the negative territory. If you're thinking about the triad down here, and any planes we might be created on top of that to be in the positive territory. So if we're to put planes on top of this, we're going to call that top plane like +1 for the first plane above the top plane, and then top plane +2 and 3 and so on and so forth as we move to the top of the tower. And you'll see as I give you that part, and we're going to be playing with later in the assembly, the upper part of the tower, that's going to have those planes in there. You're going to see how those planes are labeled. So with that said, we're going to call that top plane -1. On the top plane -1, we're going to go ahead and sketch another rectangle out, a square. We're going to go ahead and choose that plane if we haven't done so. And let's go up here and let's make sure that that's normal to. So we're going to go up here to the heads up view toolbar, click the normal to button, and now we're going to sketch that out. And while we have that all selected, let's go over here for construction. We'll make it all construction geometry. Put a smart dimension on it. On this one, we're going to make that 13 feet, 13 single quote, green check mark. And just to finish that up, let's select two sides, escape a couple times to get us out of that dimension function. We're going to click on these two sides. We're going to make those equal to each other. So with that said, we're going to go to the rebuild button. Top to sketch number 1, which is called sketch number 1 now. We're going to call that -1, top sketch -1. Now we have our 2 bits of reference geometry in there. Let's take our top plane -1 and let's go ahead and hide that. So, some more reference geometry. And yes, we're going to do the same thing we did before. We're going to grab that top plane and we're going to drag that down. We're going to drag this down about 48 feet now. And we're going to go to the green check mark. And this is going to be top plane -2, if you can imagine what we're trying to do here. But you also could call that, if you desire, we can actually call that the bottom plane. It's going to be the last plane we're going to be putting in here in the bottom part of the tower. And for initially, we're just going to be using that as a reference for a tower leg, or a main tower leg that we're going to be putting in here. So it has to have some place on the bottom in order for it to terminate. So initially, we're going to be using a top plane -2 for that. So with that said, we're not going to sketch on that, but we are going to keep it visible. So when we put in our 3D sketch, we're going to be able to use that plane in order to put that together. So let's do that. Let's just go up here to 3D sketch as our next step. While we're doing 3D sketch, what we want to do when we initiate the commands for 3D sketch is that you still have to go back over here to some of the commands that are available, and the sketch commands that are available in order to put something in there in that sketch. Initially, the first couple of elements we're going to be putting in our 3D sketch are going to be planar, which are going to be based on this line and that line. It's going to be pretty much on that plane. But then we're going to put in a support line, which is going to represent the support leg on the other side over here, which is going to give that sketch that 3D element to it. So let's do this. We're going to go to line. We're going to start with this point here. We're going to drag it down here. We can't really pick up the top plane here, top plane -3. But if we just drop it there, press escape once, grab the end point of that line, and then the top plane, we can make a on-plane relationship down here, which looks like the coincident sketch relation. One other element we want to put in here is we want to click on that line and this point over here, and we're going to make that coincident. So now you can see that that reference geometry we put together is going to help define that leg. So this is a 12-foot square and then a 13-foot square. And that line represents where that first weldment structural member is going to be for that outside leg. So now we're going to put in a couple support legs. So we're going to go back up here to line while we're still in 3D sketch. And we're going to sketch from that line, from the line that represents the outer leg. And we're going to go ahead and sketch that up. It's going to be about 4 feet off the bottom, but we're going to define that later. And we're going to go up to the midpoint of this sketch up here, which is our top sketch -1. And when we put a dimension here between this point and that point, that's going to fully define that line. So we're going to go ahead and click on this point, that point with the smart dimension selected. We're going to make that 48. 48, it's always going to assume inches, by the way, so you don't need to put in double quote. So you can just put in 48 and then enter. And that gives you an alternative to enter that 4-foot dimension in there. So as I mentioned before, that's all planar, coplanar. But this next element we're going to be putting in here is going to be the other support leg, which is going to go from this point on that top sketch -1 on the left-hand side, and we're going to sketch that down to this point here. So we're going to go back to line, click in the midpoint of that line, the end point of this line, escape once, twice, and that gives us a black line, so it should be fully defined. So now we're going to go ahead and rebuild this. So a bit of maintenance. Let's take our 3D sketch over here in our feature manager and let's go ahead and rename that to our tower leg 3D sketch. And what we have in here in this 3D sketch are the three elements we're going to be using in our next lesson in order to put our weldments together. So part of the weldments is we're going to have a path segment. If you look at this line over here for the outer leg, this is going to be the path segment for the weldment, which is going to be a structural member we're going to be putting right on that path segment. So if you think about it, it's going to be an angle iron or an L angle. It's going to be 4 inches by 4 inches by 1/4 inch thick. If you think about this line is going to represent the spine of that element, where the two wings of that L iron or L angle is going to be on either side of that. We're also going to create some sketch geometry in here too in order to line that up a little bit better. But we're also going to be talking about weldments in the next lesson too. We're going to discuss how it works, how weldments work, and why using it makes our job a whole lot easier when building a non-perpendicular structure like this tower leg. So we're going to be covering those topics and more in our next lesson.